All right, guys, so we are going to do some more modeling practice today. I also put some warm-ups in here for the quiz next week. Can anybody tell me these two are what and what? I don't know what order, but tell me what two graphs those are. One is, and one is, somebody knows this? You all need to know this for next week. One is cosecant and one is secant. Okay. I don't know just by looking at them. I have to think about what happened. If there's an asymptote here, it meant there was a zero of the original and the little u's flipped over. So that's what the original looked like. Does that make sense, guys? Do you remember that part of it? Okay, what graph did I just sketch? That's a sine. So this one must be a cosecant. Okay, if I were to do the same thing here, where there's undefined places, it must have been a zero. So it must have looked like this. That shape right in there is a cosine, so this one is a secant. Literally, that's what you're going to have on your quiz. One or the other of those pictures. I literally took a snap off Delta Math. Okay. This one, which one's tangent? Which one is tangent? What? Yes, tangent is the one that looks like an x cubed, okay? This one is cotangent. Cotangent is a possibility for the like guessing question like we just looked at on the first slide, okay? Tangent you have to actually draw. So tangent, you say, it says draw me two periods. So you would go 1 through the origin, 1 through pi. And then you have to label 2 points. So you'd have 0, 0, and 0, nope, pi 0. And then you have to label some asymptotes. So where are those asymptotes at, guys? This is for tangent, not cotangent. The asymptotes are at, what's halfway to pi? And they're vertical, so they're x equals, just kidding. X equals pi over 2. What's the next one at then? Or what's this one over here? If this is pi, oh, sorry, pen. If this one's pi over 2, what's this one over here? Negative pi over 2. And so this one, anybody know? 3 pi over 2. So that's literally what you would have to sketch and label for me, okay? And I'm basically telling you that's the question on the quiz. All right, I'm going to skip this one, and I'm going to talk about this one. Okay, that's supposed to say pi over 3. It's hard to type on this thing. Tell me something, anything. Kaylee, can you tell me anything? Shape, shift, amplitude. Okay, amplitude is 3. Adriella, can you tell me something? Good job. Elena S., can you tell me something? Yes, the midline is up at 1. How about where the max and mins are? Can you tell me that then? 4 is right. I got to go down 3, right? From 1. 1 minus 3 would be, okay, there we go. All right. The shape is cosine. What else? Period and shift, phase shift. Natalie, something? It's supposed to say pi over 3, yeah. So we're going to start our shape over here somewhere. That's really badly drawn. No news flash there. Okay. Period. Is there a b value in here? So the period is 2 pi. So the quarter points are adding 2 pi over 4 onto the shift, okay? So if we started at pi over 3, we're going to add 2 pi over 4. Type that, please. 1/3 plus 2/4, math, enter, enter. Is it 5, 6? Okay, so this first one is 5 pi over 6. If you add another 2/4, can you do that? Plus 2, onto the 5, 6, plus 2/4, because that was the quarter point. Math, enter, enter. 4/3, plus 2/4. Math, enter, enter. That would be 8, 6, 11, 6. Plus one more. 7/3? No? Yes? Okay. All right. Those were painful, but we could use our calculator. We started with the shift and kept adding the quarter points until we got them all. Now, why does it not finish at 2 pi? Because we shifted it. It finishes past 2 pi. How do you know 7/3 is more than 2 pi? How many times does 3 go into 7? More than 2, right? Okay. Do I need to put the actual ordered pairs down, or you got it? This one would be pi over 3, 4. This one would be at the midline, which would be at 1. This one would be down at -2. This one would be at the midline of 1. And this one would be back up at 4. Okay, can you do one of those on the quiz? Because that's a retake of one thing we did. Okay. The other thing you have to be able to do is write an equation. Do we need to practice this? Okay. What do you want to call this? Sine, cosine? Doesn't matter to me. I see both. Want to do a sine? Because then you won't need a phase shift, right? Everybody see that? Okay. So we're going to call it a sine. Amplitude? How far above and below is that line, midline, is it going? 1, so we don't need really anything out here. The midline of -3 goes on the back. Does it need a phase shift if we're calling it a sine graph? No. Okay. So we just got to deal with the period, which is gross, I know, but okay. If it starts here, it finishes here, so that is telling us the period is 10 pi over 3. How do we decide, though, what goes in here? B goes in here. How do you find B? 2 pi divided by 10 pi over 3. So it's 2 pi times 3 over 10 pi. Okay, the pi will cancel. I get 6 over 10, or what? If you type 2 times 3/10, you get, I think it's 3/5, yes? Because it reduces. Okay, can you do that? I just want to real quick throw up here that you could call this a cosine. On the cosine, the amplitude, the vertical shift, and the b value don't change. That's a 5. The only thing that changes is you would say it starts at 5 pi over 6. If it were a cosine shape, okay? But nothing else changes because the length of a cycle didn't change. Where it started did, but I mean, the shifts didn't change. All right. One more, or should we hold this for another day? Okay. I'll go ahead and start on the worksheet then. Number 1, this is what worksheet is this again? 23? A Ferris wheel is 4 feet off the ground. Okay, I'm gonna draw a little wheel here because I think we're gonna need it to think about something they tell us. So it's starting 4 feet off the ground, okay? Has a diameter of 26, so I'm gonna draw a little diameter 26. I don't know why I made that so tiny. I'm sorry, guys. It rotates once every 32 seconds. What is that telling us? If it does all the way around in 32 seconds, that means the period is 32 seconds. Good call. So our B value will be 2 pi over 32, which you can reduce. You don't have to if you don't want to, but okay. If you begin the ride sitting in a chair that is 17 feet above the ground going up, how high will you be 10 seconds into the ride? What? Okay. This seems a little confusing, but I don't think it's as bad as I thought. So we're starting how high? 17. And then it says we go up, right? Okay. So before I do anything else, can we figure out the max and the min just based on our picture over here? Does that help anybody? What is the maximum height you will ever hit? It's 4 feet off the ground, 26 feet across. 30 is the max. What's the min? What was the bottom height? 4. Okay. So what is the midline? If you average those, the midline is 17, yes? Oh, interesting. So we started at 17, up to the top, back to the midline, down to the bottom, back to the midline. So what could we call that if we didn't want a phase shift? Sine, ooh, yikes. Did I call it a sine? I did. Okay, I got confused that I was. All right, so what do you know? We did the period already. We're going to have a period of, or the B value of pi over 16. Do we need a phase shift? No, it started right where it should, right? The midline. What's the amplitude? How far above and below is it going? 17 to 30 or 4 to 17 is a distance of 13, which would always be the radius, guys. Radius equals amplitude. All right. We need one more thing, I think. Yeah, we need a plus 17 on the back. Okay. Tell me a window before we get too much further. It says the height after 10 seconds, but we probably should make sure it goes out and finishes at where? Anybody remember what the period was? 32, right? So let's make our window for X out to 32 at least. And for Y, what would we need? Up to at least 30 to see the top. Okay. So 13 sine pi over 16x. You can put extra parentheses around the x if you want. Just make sure you've closed all your parentheses before you put the plus 17. All right, what did we say? 0 to 32 and then 0 to 30 at least. Okay. If you get a straight line ever when you're doing these, it's most likely because you are in degrees, okay? All right. Anybody having trouble? So we could do trace 0, make sure we were at 17. Let's see, half of 32 would be 16, right? So we could say 16 seconds, that's looking right. Okay. What did we want to predict? After 10 seconds, I have 29. Let's see, if that was 16, 8 should be where the maximum occurs, maybe? Yep, that is showing up at 30. Just checking that we got everything good. What did I just say 10 was? 29.1? Feet? But everything else is working? Go to y equals. Do you have any plots on across the top? They're not darkened? Okay, can I see? Yeah. Oh, I wonder if it's your window. Yeah, your windows start at 1, not 0, and so it's not in the window, okay? It's got to be actually in the window or it won't calculate it. All right. I am going to skip to number all the way on the back, number 5. 23B then? Am I on? Okay. Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, he noticed a dead fish caught in one of the paddles. How exciting. Basically, one paddle was different than all the rest, okay? As the wheel turned, the distance that paddle, where the fish was, from the water surface was a sinusoidal function of time. So basically, it would have been nicer if I just said there was all blue paddles, but one was red, okay? As that red one went around, he noticed it goes up and down, okay? So he's watching that one paddle with the dead fish, okay? What do we know? So here's the wheel. The wheel is 18 feet across. I just draw that so we can vision what's happening here. But it says, as the wheel turned, the distance was a function of time. When his stopwatch read 4 seconds, the fish was at its highest. So 4 seconds in, I think we're going to need a horizontal shift here, or a phase shift. It was at its highest, 16 feet above the surface of the water. Okay. It took another 10 seconds before the fish reached that height again. Okay, so something happened and it wound up back up here. 10 seconds. Now, is this labeled 10 out here? No, it took 10 seconds. Does everybody understand that? So this would be at 14 seconds. So what do we know? 10 is the length of time it took, which is the period. So into the equation, we'll put 2 pi divided by 10 or pi over 5. Is that right? 2 pi over 10 or pi over 5. Okay. Now what? We got to figure out how low this goes. Okay, if the diameter of the wheel's 18, so if a point up here is 16 feet above the water, doesn't the point at the bottom have to be 18 feet down from that? What is 18 feet down from that? 16 minus 18 makes this minimum at -2, which makes sense. Doesn't the paddle have to go into the water to move the boat, right? All right. Now what? How far was this altogether? 18. So if we go down half of that, or 8, what's 8? No, half of 18 on a good day is 9. What's 16 minus 9? 7. And then 9 below 7. 7 minus 9 is -2. Is that working? Otherwise, we could have done -2 plus 16 divided by 2 would be 14 divided by 2. Our average equals the midline, which would be at 7. Would that have helped if we knew the midline was at 7? Then you could have counted up and figured 9 on either side. Okay, the amplitude is also always the radius, if that helps. All right, so give me an equation. The distance equals, what goes in first? Amplitude of 9. What do you want to call this thing? Cosine. What goes next? We're going to need an x minus something, but first we got to put in the b value, which we decided was pi over 5. Okay, we started where? 4 to the right. And on the back is what? The midline of plus 7. Whew, you guys are getting this. Okay, type carefully. Oh, well, let's write down our window quick. This time our x's, looks like we should go out to 17 because of the prediction. Do you see that, guys? So I might do 0 to 20. But your y's should be what? Like -5 to 20? We need to see some negative y, right? Again, you're just looking at what you wrote here for labels. You could do -2 to 16. So type carefully. I have 9 cosine pi over 5, another parenthesis, x minus 4, close, plus 7. Is that what we wrote? Okay, changing my window. Was it out to 20? Because we wanted to go to 17, right? And then I think I wrote down -5 to 20. Oops, not -520. Oh, pretty purple. How we doing? I think I'll slide this onto the slide and maybe the window. Did that work or not? I'll put those at the bottom in case anybody needs them. All right, can you type in our predicted and see what you get? What do we want? 5 and 17. I gotta go back here and go trace. 5, I have 14.3 and 17, 4.2. 14.3 and 4.2, is that right? Was it feet? Okay, those were the distance above the water. Okay, one more. I just want to do number 6 because I'm not sure this gives us a whole period. We got to think about this a minute here. Naturalists find that the populations of some kinds of predatory animals vary periodically, okay? Assume that a population of foxes in a certain forest varies sinusoidally with time. So record keeping starts when time equals 0, and okay, so we started when time is 0, but I don't think we know how many foxes there were because it says a minimum number, 200 fox existed when it hit 2.9. Okay, so there's no negative foxes, but 2.9 in, we were at a minimum, it says, of how many? 200 foxes? It sounds like a lot of foxes. It must be a very large forest. Okay. And that's the minimum number because the next maximum occurs at 5.1. And that was 800 foxes. Okay. Now, I didn't bother to go back. You could go back to the left and try to make this a cosine. I'm thinking maybe it would be better if we make it a negative cosine. Do you see that it's doing that shape? But what we need to figure out first, is this a whole period? No, right? If we keep going either direction, we'll hit a full period. What's 5.1 minus 2.9, somebody? 2.2? Okay, so what is another 2.2 after that would be 7.3. Or we could go backwards if we wanted a 2.2, but I didn't leave myself room. Okay, I really don't need that 7.3 number. What I need is the length of a period. How long is a whole period? 2.2 plus 2.2 or 4.4. So the B value is going to be 2 pi divided by 4.4. I'm just going to leave it that. If you want to reduce it, I think it's like pi over 2.2, or maybe it turns into a fraction. Anybody do 2? It's 5/11ths. I think that might be what I put in. If you type 2 divided by 4.4, do a math, enter. But it will work if you type 2 pi divided by 4.4 into the equation. All right. What do you want to call this then if we're doing this shape? Yeah, I'm going to call it a negative cosine. If we add these together, we get 1,000 divided by 2 would be 500. The average should be our midline. Does that work? What's the amplitude then? Make sure it's in the middle. 300 and 300. Right? 200 plus 300 is 500 plus 300 is 800. Okay. So which number goes out front? The 300. Then it's a cosine, but I already messed up. We need to have a negative out there to show that it's upside down. Okay. The period, I will write down here 2 pi over 4.4, but I think on the calculator I did 5/11ths. Do we need a phase shift? To the right, 2.9. Yep, I have no room. On the back, there is a plus 500 was the midline. Okay. So this one is long. I have negative 300 cosine. Okay. Window. Left to right. They just want to know at 7. So if we even just do 0 to 8, we'd hit it, right? When you go back to 0, you got to remember there might be some more stuff over here, right? The graph is going to show some junk over here that we didn't graph. That's X. And what about Y? 0 to 900, that would work. You could even do 200 to 800, but yep, I would have probably done a 0 number 2. Gotta go back and turn this on. Ooh, this one's orange. I'm excited. What did we say? 0 to 8. And 0 to 900. All right. So what should we check? 2.9? Was that what we first put in? They told us a value. Was it 2.9, a minimum of 200? Yes. Yeah. And then we did, and 5 point something, was it 5.1? It's supposed to be up at 800. Woo! Okay? I always check that it's working, because if I wrote it down and I typed something in wrong, like I did yesterday, then it doesn't check and you know something's wrong. Okay. What did they want? 17? No. 8? 7? I'll just make up some numbers. Okay, they wanted to know at 7, so if we round to the nearest fox, I have 227, yes? So 200, oops, that's this answer. Okay, I like this next question, but I wouldn't put it on the quiz necessarily. They were declared an endangered species when they dropped below 300. Between what 2 times were they first endangered? Can anybody remember how we might do that? Yeah, put in a line at, what did they say, 300? So somewhere put in a y equals 300. And then between what 2 times were they first endangered? So we want to find this intersection. Remember doing that? Second trace, intersect. And then I'm going to scroll close to that first one. And then I should be able to just hit enter. It doesn't matter. It's going to find the intersection. I'm hoping it's going to find the right point for me. Is that 2.3? Okay, I have a lot of extra equations in, so I was a little worried, but 2.3. Did anybody else get that for the first one? And then the second one, if I go second trace, intersect, this time I got to scroll over to that second point. And then I should be able, once I get there, to just hit enter, enter, enter. I got 3.5. And I think those were years, yes? Time equals 0 years, yeah. All right. I don't care if you have parentheses, brackets, nothing. I'm not going to ask that on a quiz anyway, but it was interesting use of the equation. All right. So, I don't know how much time we have left. Not a ton, but you need to do 2, 3, and 4. Okay? Work with somebody in here. The key has all the answers and everything in Google Classroom. This is not something you should just copy from the key because it won't help you learn. And next Monday, we're going to review law of sines, cosines, and area. So please make sure you've done that delta math from last week, okay? Some of you have, but some of you didn't ever do any of it last week, and that makes me very nervous.